Okay, what you're looking to do next sort of 45 minutes, I'm going to sort of run through the sort of agenda you can see. So a quick overview of what we actually mean by microgrids, because it does mean different things to different people. What are the drivers? And this is really important. So one thing I'd really like you to take away from tonight is that it's not the technology that's driving the opportunity at the moment, it's the commercial drivers, and I'll talk about that in a bit more detail. What the applications are for microgrids. Digitisation, that's all around us, as we've just seen tonight with this amazing webinar. What's the impact of digitisation going to make on microgrids? And I've got a case study at the end. But as we heard earlier on, if you want to ask questions as we go through, I'm happy with that, or you can save them up till the end, or my contact details are on the presentation, so you can send me an email and I'm more than happy to answer. So what do we mean by microgrid? You've probably heard the term smart grid and you've probably heard the term microgrid. So what's the difference between the two? So on the screen is our understanding. This is obviously from a Schneider perspective, and it is generally the industry's perspective as well, of what a microgrid is. And what we basically are trying to do is to control the generating assets, as you can see on the sort of top left-hand side there. So it could be a CHP, it could be just a straightforward gas generator, wind turbines, and some solar PV, with a controllable load. And that's one of the key things. It's a control, like a VSD, HVAC type of system. So you've got a controllable load down on the bottom right there. And you may have, as you probably will have, if you're grid connected, you'll have an import from the grid. A lot of interest is being shown at the moment around energy storage to support the microgrid in a number of different ways, and I'll come on to that a little bit later with the looking at the drivers. So what we actually mean by microgrid, it's the controlling of the assets, and it's the controlling of that controllable load to optimize where the energy is being distributed, depending on a number of different drivers. The way I sort of typically explain this, a long time ago when I first started my career, I used to be I was in the Royal Navy on HMS Hermes, and our driver was all to do with risk. So this big aircraft carrier in the centre of the Atlantic, not much risk. So we would have 2 1-megawatt steam turbine generators providing electricity. When we used to do replacement at sea, when the tankers used to come alongside, or we used to go into harbour or out of harbour, slightly more risky, we used to run up a couple of diesel generators. The actual load on the system is very similar. It was just that it may happen that we need more power quite instantly. So the optimization was all around where the energy flow is going. That's what we're trying to do here. So depending on what the customer drivers are, we'll optimize how the generator is running and how that load is being supplied, with or without energy storage. So what do we actually look for in terms of microgrids? What are the different types of microgrids? So from a historical perspective, they really started on the right-hand side, off-grid or autonomous. So I did some research a long time ago with Rupert following me, the back of the class there, at a local farm here. And that was really sort of off-grid, but grid-tied at the same time. But really, it was an isolated farm. And that's where the opportunity really developed. So sort of 20, 25, 30 years ago, it was sort of academic, it was sort of a bit left field, it wasn't commercial, but it was providing power where there wasn't a grid connection. And that's really where a lot of the research and academic work was carried out. On the left-hand side, you can see grid tied or grid connected, and that's what we're all familiar with. So if you've got PV on your roof at home or PV on this building, running in parallel with the grid, that's we're all relatively familiar with that. The opportunity, the business opportunity, is really in this middle section here, what we call island mode, where it may be you want to be disconnected from the grid for commercial reasons because you want to utilize more of your own energy. If you're bedding more renewable energy in, it may be you're forced to have a disconnection from the grid because you've got a weak grid. What I mean by a weak grid is if you look at the southwest of England, around Plymouth area, they quite often have blackouts or brownouts where the grid goes down. If you've got a manufacturing process, you know, the loss of production per hour, it can be quite astronomical. I've been hearing figures, I can't say who, but certainly in the UK, large manufacturers, £100,000 a day, you know, that adds up quite a lot. So the opportunity for ourselves and our competitors is really around in that middle section in the island mode. So what are these drivers that are coming through? So you're probably familiar with a lot of these, but I think it's just worth describing them in some detail. I mean, the biggest thing is, I think we're all familiar with, is the rapid increase in the population growth. Obviously, at the moment, you've got the climate change conference over in Poland. David Attenborough speaking, was it yesterday, of the impact of global warming, etc. That's all part of it. The rapid increase in the population, is a lot of that's going to go into urbanization. Developing countries coming through, they want access as well to energy. And we're moving towards an electrical economy as well. Certainly from an appliance perspective, a smart perspective, and transportation as well, electric vehicles. That's in the UK, certainly we're looking at new cars, 2040 are going to be electric. How we utilize those cars is going to be interesting, because there's a lot of thought now around a sort of Uber type of operation of cars. So most of us who've got cars, roughly it's about 95% of the time your car is doing nothing. It's just sat in a car park or on your drive. Okay, why invest a lot of money, tens, 20, 30, how many thousands of pounds you spend on a car when actually for 95% of the time you're not using it? Go flick to a Uber model. So when I leave here, I just go onto my app and I order a car and it takes me home and then it goes elsewhere. Okay, that's potentially where the market is going towards. So that may help to off balance the increase in the electrical usage, but time will tell, nobody really knows. So electricity demand is increasing. That obviously knocks on to the CO2, where we can see there how much as a percentage the CO2 is being contributed from electrical generation, but it does depend on where and how that electricity is being made. And obviously if we move towards cleaner sources, moving more towards renewables, then that is obviously beneficial. Okay, big thing, resilience. Not so much in this country, but certainly if you look last year over to America, you know, they had some horrendous hurricanes. We had the beast from the east in this country earlier on, where you've got issues around grid resilience, and you can see the figures there in terms of the cost and in terms of the power outages. So that is certainly from our own company's perspective is a large opportunity in America. What you're also seeing, as I touched earlier on, is gaining access to energy. You can see the global population don't have access to electricity. The UN are mandating around improving living conditions. So all of these drivers are all in the mix and are creating opportunities. Okay, so we're just sort of funneling it down now. So that's a sort of more of a global perspective. If we now look at a sort of UK perspective, so the figures here historic, ranging from 1990 over to last year, 2017, so a 27-year time shift. So you can see how much this is just purely electricity generation has changed over that really short period of time. Okay, so the coal has dramatically reduced. Yeah, as you can see on the grey chart. We'll see lots of other charts that even straight a bit more. And what you're seeing at the top is greater utilization of renewables. So if you just take a snapshot of last year, so the pie chart you're seeing now is just the representation, obviously, of the last year on the previous chart. But what it's showing you is on an energy, so in terawatt hours, nearly 30%, 29% of electricity was from renewables. So what we're seeing here on the right-hand side is, you know, best part of 30% of electricity being generated is from renewable energy, which is amazing. Compared to, if you look back at 1990, just under 30 years ago, it was next to nothing. But a lot of that is offshore wind, okay? But as you're seeing, as you drive around the motorways in the UK, you'll see large solar farms coming along. I'll touch on that a bit later. I think this is amazing, this next chart. This is from CIBSE, part of the UK government. So this is a forecast. So we've looked at historically what's happened, yeah, from 1990 up to last year. Now we're looking ahead from 2017 up to 2035. So these are the UK government's projections. So the bottom line is basically coal. Coal generation is effectively going to disappear from this country unless they've got carbon capture and storage. So 2027, what's that, 8 years away, is going to disappear. What you see is nuclear power will kick back in again once they're built Hinkley Point, and that's accelerated. Obviously, this is a forecast. Remember, starting to ramp up. The blue line is the descending blue line from top left to bottom right is gas. So the gas is going to decrease. I think the important thing here to bear in mind is the green line at the top, which is renewables. Not just that it's increasing, but if you look at the y-axis, it's effectively doubling. The amount of renewables is doubling in the next 20-odd years. Yeah, it's phenomenal. What you're also seeing is a rapid reduction in the cost of, we've got renewables, PV and battery storage. I could also put on wind turbines as well. So you've got economies of scale have kicked in. So all the concerns around feed-in tariffs being slashed at, a number of years ago, it was justified because the economies of scale have been driven by those grant mechanisms. So what does all that mean? It means that we're in disruption, or the new president of the Energy Institute was talking around a chaotic revolution. So all these drivers I've just talked through from a global perspective, a UK perspective, that is what is driving the business opportunity for microgrids. It's not the technology, because we'll see, it's what can you do to a building. You can do PV, wind turbines, possibly CHP, you can do energy efficiency measures, put a CHP in. So all these technologies have been around donkey's years, many years. It's just that those commercial drivers are now in place, or the stars are aligned to make the microgrid, or a smart grid, which is a larger version of a microgrid at a sort of citywide level, community level, viable. Okay, so please take that away, because that's one of the big learnings you need to take on board. Yes, a question?
Yeah, I can see how the price of lithium-ion batteries is reduced.
Yeah.
But how does a lithium-ion battery give you the ability to store a large amount of solar energy in the summer and then use it in the winter?
Okay, good question. Right, one of the reasons why batteries are being utilised now, or energy storage, is because of the instability coming now onto the grid. So with the coal-fired power stations closing down, instead of the grid frequency, you can't see this on the webinar, but the frequency was relatively stable because you got rotating inertia. Now you're moving to more intermittent renewables, so wind turbines and PV and inverter technologies, so you don't have that inertia. Okay, so that opens the mechanisms for the national grid to offer grid balancing mechanisms, demand side response you may have heard of, fast frequency response mechanisms, where companies, organizations can sell electricity or load shift, and I'll show you some examples later on, shift some of their load to help that grid frequency. So the idea with storage is to complement the intermittency of the renewables, okay, on a more dynamic basis than what you're suggesting, okay, in terms of, yeah, you can store it from on a seasonal basis, but that's more when you're storing sort of water systems, really. So just sort of wrapping up in terms of the drivers, this is interesting, because what this is also showing is the intermittency and the change that we're going through in the UK. So starting at the bottom, just to keep you on your toes, so Q2 this year, nearly 32% of our capacity being generated was from renewable energy, so that's increasing more from last year. The demand on the transmission grid was less in the afternoon than during the night. Normally it's the other way around. This was last year. Okay, that's because of large amounts of solar PV. Can't say coal-fired power stations are closing down. So you can see last year we went through one full day without utilising coal for electricity generation. So all these dynamics, all this flexibility, intermittency, are making the opportunity for microgrids much more real. So if we move on to what we all have grown up with, and this is a classic supply-led business model. Central, big generators, Ratcliffe Power Station, 2,000 megawatts just north of Leicester, generating electricity through the transmission distribution network to the end users here at De Montfort University or in our own homes, wherever it may be. I think we're all familiar with that. So what we're saying is this disruption, okay? So you have these, what we term distributed energy resources, or if I use the acronym DER, so this is what I mean, distributed energy resources. So large wind farms, large PV systems, okay? They can also be other assets that are being utilized in terms of electric vehicles. We've touched on that a little bit around smart technologies. So the idea is we're moving towards more decentralized generation, more informed users, consumers. Who's got a green energy tariff? You're better than the last crowd I saw, they had none. Okay, so why have you chosen green electricity? Because you're green, because you're informed, you want to have that choice. If you go back to 30, 40 years ago, you didn't have a choice. You just bought, probably 10 years ago, so I say 20 years ago, you didn't have a choice. You just bought electricity. You know, it came, or my parents would have bought electricity and signed the bill and off it went, yeah, paid the bill. We have a choice, we're more informed, okay? And that is driving the market. We're moving away from this supply-led industry that we've all grown up with to a demand-led industry where the users, you and me and the guys on the webinar and elsewhere, are much more informed about where they want their electricity, where they want their energy to come from. We've all got one of these, haven't we? It's a smartphone, by the way, I'm showing you, a mobile phone, okay? There's a term called prosumer. It's a producer and consumer. It's an acronym. It's condensed together, okay? And that's what we're moving towards. And I'll touch on a little bit this later. But we're all prosumers in our own way, because if I switch this on, I'm consuming energy from the battery that's sat in here. If I charge it, I'm consuming energy. Yeah. So we're all prosumers in our own little way, using a mobile phone. Or I say if you've got solar PV on your roof, or electric vehicles. We're all prosumers. Okay. So let's move on to the applications. So you're going to see 4 slides the same, but we're going to move around in a clockwise manner, starting with prosumers. Okay, and these are where the opportunities are and the applications for microgrids. So the sweet spot really at the moment is in the top right, single owner, grid tied or grid connected, a campus type of environment. A De Montfort University, a Leicester University, Leicester Royal Infirmary, schools, academies, because they have the infrastructure, the electrical infrastructure and the demand at a relatively high level to make a microgrid commercially viable. So the drivers, why would they want to do that? Because they want to, minimize the bills. They want to look at the opportunity for integrating renewable energy, reducing their carbon footprint down. It may be, as I've said, it might be manufacturing sites. They've got issues with resilience, okay, blackouts and brownouts. If we move round on a clockwise basis to the bottom right-hand quadrant, what we call eco districts or smart communities, that's just bigger. That's where the smart grid comes into play. So that's a multiple of microgrids. So technically, yeah, a little bit more challenging. That's not the real issue. Where the challenge is you're now moving away from a commercial perspective, from a single contract with a single client, like a university or a manufacturing site, to now working in, say, in Leicester, where you'll be working through different procurement mechanisms. So you'll be working with the council, probably the local economic partnership, business leaders, etc. So it just may convolute the contractual negotiations. So technically, yeah, a bit bigger. Contractually, more people involved, so it will take longer to happen. But they are happening. If we move around to the right-hand side, I say this is really where sort of the microgrid world all started in isolated communities, as I sort of touched on earlier. So if you look at Tonga, they import 95% of their, or 95% of their energy is from imported fuel. Okay, so the opportunity for them in terms of resilience, you know, their risk is the fuel doesn't come. Okay, so if opportunity to utilize storage with renewables to you know, flatten out the seasonal patterns is very beneficial for them, and obviously cost reduction and environmental benefits. And sort of quite similar really up onto the top left-hand side, top left-hand quadrant rather, sort of remote sites, sort of mines, military bases, may have some issues around security, if obviously it's with military bases, but it's all the same concept really. It's around energy and integration of renewables and carbon footprinting. If you look around the world, the requirements do vary, as you would suspect. So if you go from west to east, so if you start in North America, I've touched on the major reason why microgrids are being utilized in America, in North America anyway, is around grid resilience. Okay, because of the blackouts, the bad weather that they have over there. Okay, and also in terms of the economics, in terms of gas prices. In Europe, we have a stronger grid, certainly on mainland Europe, and certainly around in Germany, they have a much and perhaps a more social awareness of these sort of issues. I mean, Hobart can probably explain more about it later on, but there is a strong push there. Less so in France because they're predominantly nuclear. The UK, big opportunities, let's say in remote communities, some of the island communities, and also where we have that weak grid. And then you move right across to the east in Asia. That's sort of more the remote side. Australia, we're sort of working out there as well, where there's issues around importing of fuel, etc., and the costs associated with that. So the drivers, as you just suspect, will be different. And if we designed a microgrid for De Montfort University here in Leicester, it'll be different to Leicester University because the infrastructures are different, the drivers, the commercial drivers are all different. So it's a very bespoke offering. However, before we do all this stuff around microgrids, there's some fundamentals that we need to get in shape first, because the most cost-effective use of your client's money or your own money is to actually drive your energy demand down, because what that means is the cost of your microgrid or the size of the microgrid that you need is reduced. So working from left to right, the chart on the left-hand side with prosumer outcomes, what that is really trying to do is to balance the three elements of what we term active energy management, or you may have heard the term trilemma, or many years ago for the older generation, it was triple bottom line. It's all around sustainability. It's all around the economic security of supply, getting those into balance, driving your demand down. I think that's the most cost-effective thing that you can do. Once you've done that, in the implementation of a microgrid, what you really need to do, certainly for an existing build, an existing building you're trying to integrate a microgrid in, is to really understand the architecture, the electrical infrastructure, because if you're putting on storage, if you're putting in PV systems, you're introducing inverters, you're introducing harmonics onto the system. You need to understand the fault levels, the switchgear arrangements. You're going to start introducing two-way power flows, as you can see here. You know, it may be your cabling isn't large enough. Okay, if you're working on a new build, then all these design factors can be built in. But where you have, I say, an existing build, then you have to be a little bit careful. So certainly a lot of power study work is carried out. So once that's carried out, then you go through the normal process of, you know, scoping studies, detailed studies, etc., going out for tenders for different suppliers, moving through to installation, and then you have the optimization. So like I said, like my Navy days, you're optimizing where the energy flow is going to happen, depending on what the drivers are, but I'll touch on that on this very next slide. So starting at the top right, you will see what the drivers are for the client. Now, maybe they want to utilize a weather forecasting module. So the system that we have, we predict a 72-hour forecast. which is very useful if you've got sort of weak grids and you know bad weather's coming, you've got energy storage, so you can store your store energy up for the weekend when no one's going to be there, so your critical loads are met. Water companies are quite interested in this if heavy rains are going to fall or you've got seasonality. It may be in terms of pricing that you just want to make shedfuls of money. So you import electricity when it's cheap, store it in loads of batteries, and you just sell it back to the grid when it's high. And that's lots of number of businesses do that in large containerized units full of lithium-ion batteries. It may be you want to take advantage of sort of more grid balancing mechanisms. So you're sort of load shifting. So you're utilizing storage to be able to supply the sort of red band zones, sort of 4 till 6, 5 till 7. So you're minimizing your load or peak shaving. It may be you want to sort of talk about client constraints or client opportunities around embedding renewables. So it may be you want to utilize more renewable on your campus. So certainly for universities, you know, the opportunity to utilize more renewable energy helps them with their sort of green league tabling, it helps with students, etc. So there's lots of different drivers. So depending on what the drivers are for the client, or do you be dependent on what actually is driving how the energy is being distributed between the DERs that you can see on the bottom here. Okay, so it's quite a simple exercise. Okay, you're just managing the energy flows depending on what you're being told by the client, and that's as simple as that, really. So what actually makes, or what are the constituent parts that you need to have within a microgrid? We need to understand where you are at the moment. So on the bottom line, you'll see the protection and metering elements. And this is quite key. Certainly, well, it's critical that the metering element of it, because you can start here in, where we are now, 2018, and you really need to understand what your energy consumption is, utilizing half-hourly data. Hopefully you've got some sub-metering in as well, so you can analyze what's happening where. Minimize that demand down, then how can we utilize, depending on what your drivers are, say you want to utilize more renewables, looking at greater utilization of PV, maybe have a wind turbine. How can that be best managed? Because over there in 2025, what's that, 7 years from now, you want to have a 20% carbon saving. If you don't meter it and you start over there in 2018, you won't know when you get here if you've actually saved that 20% carbon saving. That is often, or quite common, a misgiving in some of the designs, because when you do the design and it comes above budget, what can we take out? What can we rip out? Metering. Well, don't need that, don't need that, don't need that. But when you try to tell your finance director where you've got to in 2025, it can be a bit tricky. So don't underestimate the importance of that, and stand up when you get challenged around metering systems, monitoring systems get taken out, because you really need them. We've touched on power quality, we've touched on issues around flexibility and sheddable loads, critical loads, etc. So, and protection systems all around that, the power quality. We moved up to the next line up is all around the DERs that was touched on. You know, are you going to introduce more assets for control? You know, what are the assets that you can control? What are the generating systems that you have? Do you need to bring some in? Do they need upgrading, etc.? Are they suitable? You then move on to the microgrid controller. This is just really, it's a PLC, for another better words, but that's controlling how the energy is being distributed across these the DRs, and that is getting its signaling from the supervisory systems on the top here, okay, from sort of typical SCADA type of system. What you also need to understand if you're looking at a microgrid on an existing system is the IT protocols. Typically we use a Modbus system, but there are others around, and if you've got different communication protocols across your campus, then you need to make sure that they can actually all talk to each other, because otherwise you've got a bit of a problem. And then typically we have cloud-based services, so analytics, understanding how the system is working, fault levels, fault analysis, fault signals coming in. So you get a sort of real-time view of how the system is operating and performing. So looking at some of the, sort of going into a bit more detail about some of the asset controls, one of the very simple things I say, looked, I'm sure Rupert as well, in the early days of microgrids was very simple sort of load shedding, okay, to maintain your frequency. Okay, it's still doing now, but it's on a more automated basis. Obviously, what you need to make sure is your sort of critical, non-critical loads have been determined. And as I said, this is sort of summarising a little bit what I've talked about already. So when you're looking at microgrids, you really need to understand that you're moving into a new world of bidirectional power flow or energy flow. Okay. Gone are the days, well, I say gone are the days, the days of centralized generation will still be around because we're going to have nuclear, we're going to have CCGT for some time, we'll have large scale wind farms, but the dynamics are going to change because we're moving towards the more consumer, a more demand led world, okay, rather than from a historic supplier, large, you know, the big six telling us what, you know, our energy price on where it's coming from. So yeah, so we're moving towards this flexibility, and it's that flexibility, that intermittency, I say, is driving the opportunity. What you also need to understand is around the commercials. So looking at there's different ways of doing this, just highlighting here the levelized cost of electricity. So you're looking at, you know, how much energy is being generated over the lifetime over its installed cost. When you actually break it down, touching on your point earlier around battery storage, it may not necessarily be the most cost-effective thing because these things don't come cheap. There's a rough guide, a 1 megawatt battery, lithium-ion battery in a 40-foot container, 1 hour discharge, you're looking roughly £1 million, okay? Don't come cheap. So you need to make sure is the business model stack up? Okay, and there are different business models, power purchase agreements, energy as a service, and there's lots and lots of money around. Investment houses, equity is coming into this market because it's a lot safer for some of these businesses, the investment houses, than investing money on the stock market and other opportunities. So as you're carrying out these, you know, do your commercial modelling, looking at where your finance is coming from, carrying out, we've touched on this already, in terms of the engineering that you need to be carried out, looking at fault levels, your harmonics, your discriminations, levelling, and your switching speeds with batteries as well. Okay, that's quite critical if you're utilising UPS systems. Okay, so what we've got here is a example of a sort of battery system helping to maintain the demand for a particular organisation. So you've got two charts. So on the top side, you've got the site consumption. The black line is the site demand, and the blue line is the grid import. The bottom chart, you've got two lines. One is the solar PV, which is yellow, and that follows a typical diurnal pattern, as you can see. And then the green line is the battery, which is being charged in the off-peak modes early in the morning and also early afternoon, and being discharged later in the morning and in the red band zone. Okay, so what does all that mean? It means that from a commercial perspective, this particular organisation is not exposed to the high tariffs. Okay, so if you go starting from left to right, so that you're charging in the off-peak between 3 o'clock and 7 o'clock, and then you're discharging your battery during the on-peak periods, which is the period between 4 o'clock and 7 o'clock in the evening. So you can see it's below the line there, so it's charging, and it's discharging on the right-hand above the line here. So that's why you've got a large gap on the chart above between the demand and the site consumption here. Okay, that's being met by the battery discharge and also some of the PV as well. The time in the middle of the day where the battery is discharging from 9 till 12, that's helping to offset, is to drive down, you peak shaving the demand from the grid. So if you actually look at the red line, you've got peak demand at between 9 and 9:30. You can see the site demand is actually higher, but the grid import is actually lower because you're discharging the battery. So you're not exposed to the high charges that you would have if you didn't have that battery there. Okay, let's move swiftly on. So digitisation. You may have come across these terms: digitisation, decentralisation, and decarbonisation, all the 3 Ds, or actually there's a 4D version of it as well. But it is amazing in my lifetime, or perhaps last 10, 20 years, how much society has moved to becoming much more smart, enabled, digitized. Some younger people here, iPhones, iPads. I struggle with some of these technologies, and it's just second nature. We buy a new car now and it's got pressure sensors on your tires, so you don't even have to go to the garage to test the pressure in your car. You can just press a button on your car. Sensor technology is really driving this opportunity. And what you're seeing on the left-hand side is just a very conservative estimate of where digitally connected devices are going to are driving a whole society. We've touched on decentralization, and we've touched on the amount of investment that is available in renewables. So if you tie these 3 things together, and it's not just from a Schneider perspective, this is just a snapshot of 4 other companies. You've got a blockchain company, actually Electron, who presented here earlier in the year. You've got Hitachi, you've probably heard about, large sort of company. You've got a online energy storage website here, and you've got an online blog. So these terms, decarbonisation, decentralisation, digitisation, and possibly democratisation, the 4 Ds or 3 Ds, it's out there. Okay, it's happening, it's there already. It's changing our society. So if you look at the bottom left-hand side here, what all this means is the bits I've been touching on here really is around the sort of human factors, okay, and the social interconnection. The demographics are changing. In 2020, 50% of the workforce will be millennials. It's quite staggering. So a lot of the how do I describe this? A lot of experienced knowledge that may not be captured through the digitization will be retiring, will be leaving businesses, organizations. Okay, so can be a huge hole there. So what we have now is the opportunity to capture a lot of that information through the analytics and helping to make decisions. The technology dimension, the top left-hand side, we've touched on around the sensor technologies. Biotechnology and neurotechnologies are also driving this market as well. So the combination of those 2 are really opening up these markets that you can see on the right-hand side. So we've talked today around energy storage, around renewable energy. We talked around sensor technologies. We had the presentation earlier on this year around blockchain from Electron. Blockchain, and I'll touch on a little bit, is really going to has the potential to really change how we procure and utilize energy. So all the systems, the process on your right-hand side are really being driven by the digitization of our society. So it's not just microgrids, there's a whole range of industry that is being affected. So in summary, I could just show you this one slide because this describes everything I've just talked about. So if you start off on the left-hand side, where I was 40 odd minutes ago, this is big generation. This is the Eons, UN powers of the world, or we're moving away from that. Okay, we're moving across to the right-hand side to the distributed one, because so half a dozen of us have got green tariffs because we want to have a choice where we get our electricity from. As a company, Schneider, all our products now are all grid enabled, so you can actually monitor them. You can actually see what's happening condition monitoring systems. As a young apprentice in the Navy, I used to go around and check dashpot fluid and dashpots on starter motors because I was told to do so by my chief petty officer, because he was told to do so by his boss, etc., because of some planned maintenance system. Those days have gone now. It's all around condition monitoring, because you have a little sensor in that starter motor which tells you if that motor is performing, if it's overheating, etc. Individuals, companies have become much more transactive, more transparent. You know, we have requirements around carbon reporting. You know, organisations are being much more transparent about their own businesses, becoming much more proactive as well, more strategic. Blockchain, the opportunity for smart contracts is going to revolutionise not just our industry, but a lot of other industries around the ability to have that immutability of contracts. Okay, that opens up the opportunity for peer-to-peer trading. So if Rick's got PV on his roof and he's away on holiday, away for the weekend, a sunny day, and I'm his neighbour and I'm happy to buy his electricity, he can sell it to me direct. He doesn't have to go through all the different third-party operators. So he gets a better price, I get a better price. So it's going to revolutionise the whole market. Okay, quick case study. So the reason I've chosen this is mainly because of this side. It's on the right-hand side, the commercial arrangement, but I'll just describe to you what it is. It's Boston One campus obviously in Boston, in America, sort of 1 megawatt size. It's a Schneider R&D center. As I sort of touched on earlier, if you look at the scope on the bottom, what you'll see is the range of DERs. And I could show you 10, 20 case studies, and those DERs will all be very similar. PV, electric vehicle charging, battery, wind, CHP. Okay, there's only so much you can do. Yeah, but it's how you utilize that energy across those devices and your assets is where the opportunity lies. And the reason for showing you this particular slide, this case study, is it's a PPA arrangement. It's a power purchase agreement with a company called Duke Renewables. It says Duke Energy, it's actually Duke Renewable Energy over in America. So they're the investor. Schneider have provided some of the products into the building, but basically we're on I think it's a 15-year PPA, so we're just basically buying the electricity from Duke Renewables. What does that mean? It means we don't have to outlay however many millions of dollars it was. We just buy on an ongoing basis. So we have no capital upfront cost avoidance. Then, because of the microgrid is now in place, we have better resilience and better carbon footprint, etc. I'm just going to show you a video now, which hopefully you guys on the webinar will be able to hear, which just goes through this Boston One campus, about 2 minutes long.
I truly appreciate New England. I was born in New Hampshire. I love the 4 seasons. I love the change of seasons, the variety. The energy management landscape is always changing as well. And at Schneider Electric, we work hard to be leaders in that space. My name is Ed Muskis. I'm the site general manager for Boston One campus here in Andover, Mass. Boston One campus houses 4 of our 5 business units for R&D development. So it's extremely important that this building is operational 24/7. So we signed up here to implement a microgrid as a service project, partnering with Duke Energy Renewables and REC Solar. A microgrid is a system that allows us to automate and control distributed energy and determine where we draw our energy from. For example, solar generators, the grid power, and in the future, battery as well. Another innovation was microgrid as a service, the end-to-end solution where, as a customer, I don't worry about financing it, I don't worry about maintaining it. I just gain the benefit of reduced cost and uptime of my facility. For us as a customer, the third benefit was to maintain this building as a living laboratory for the further development of that technology. For example, the Energy Control Center, which allows for the automation and control of the overall system. And EcoStruxure Microgrid Advisor is software and allows us to view the energy generation and consumption of the solar microgrid. I really think Schneider Electric is leading the digital transformation of energy management and automation. We have to do more with less, and the solar and microgrid technology provide customers the opportunity to have a choice of where they get their energy and at the same time to reduce their costs.
Okay, so let's just conclude then. So microgrids, it's a local interconnected system, okay, campus type of environment. A smart grid is really in front of the meter. Microgrid is behind the meter on that campus or that manufacturing site, hospitals, etc. Okay, smart grid is taking other factors as well, but can be we integrated microgrids into that, and it's, I say, on there in a clearly defined electrical boundary. It includes loads and generating assets that you can control. Again, that's the key thing. You must be able to control those assets, those loads. Obviously, storage is coming in to help with that intermittency in grid balancing mechanisms, but maybe you just want to utilize it to utilize more embedded renewables. Okay, so lots of different drivers there. And we have, it is a, as I say, an independent control, either in its grid connected system or in an island type of approach there. Typically, what you're seeing, most projects are sort of grid connected in one manner or another. And the power range, just to finish off then, is, it can be from small kilowatts up to multiple. Generally, they are sort of in the megawatt size of range. And when you look at some of the projects we've been involved with battery technology, it's hundreds of kilowatts, 500 up to be a 1 megawatt solution for a campus type of environment. There are systems much larger than that.
If we look at the UK,
yeah,
we've had a long track record of making changes and then really messing them up.
Yeah.
So we've got carbon reduction commitment.
Yeah.
Everybody put meters in.
Yeah.
And they changed the system.
Yeah.
Demand side response. Put a market out there, £47,000 a megawatt. Then the market collapsed to 3,000. Now they've had to stop the scheme completely.
Yeah.
Because it doesn't meet EU rules. My barrier for batteries is the fundamental inefficiency of them.
Yeah.
The fact that for every 100 kilowatt hours I put in, I only get 87 out. So it seems to be very much a finance game. What needs to change in the UK market to really accelerate the use of the microgrids?
Good question. I think there's two elements there. Yeah, I think the drivers need to, obviously it's difficult to predict what's going to happen. We've got Brexit looming ahead of us. Without that, even if we stayed in the EU, there'll be uncertainty around political agendas. Nobody really knows. But we do know is, at the time we've got this, climate debate on over in Poland. The issues around greenhouse gas and global warming. So I don't think that's disputed. The impact of that is the increase in renewables on the intermittency on the grids, and that's creating this uncertainty from the national grid perspective, because let's say the stability of the grid through the rotating inertia of the large generators is disappearing, and we're moving towards this intermittency. That opens up the opportunity for batteries. So I don't think that's going to disappear. Coming back to your second point around the technology, the way I think about it is we're in a transformation period. It's a bit like James Watt over in his little steam engine, yeah, and Mr. Ferrari over here, yeah, in quite a short space of time, 100, 150 years, okay. I think what you'll see is it can be a step change in technology. We're utilising lithium-ion batteries. When I did my research back there, it was on lead-acid batteries, old submarine batteries. So over 20 years, gone from lead-acid to lithium-ion. Research 10, 20 years from now will lead us to believe we're going to have lithium-air batteries and solid-state batteries. I can only quote what I've been reading. Rupert might be able to allude to provide some more detail, but from what I'm seeing, lithium-air in research labs 30 to 40 times more efficient. if you say they're only 5 times more efficient, 10 times more efficient, okay, that's a sort of step change that we need to see. It's the change in that technology that will drive that opportunity more in not just in this country but elsewhere as well. Any other questions?
We have a couple from Tim.
Oh,
okay, Duncan, I've got a question. Just what about, you've answered one of them, you just answered one, but there's another question about the environmental impact of this container of lithium-ion batteries. If it's anything, well, if it's anything like my laptop, in about 6 months' time, when it doesn't hold charge anymore, what happens to that? What happens to that big mass of very nasty materials?
good question. In terms of the lifetime of batteries and how they are operated, that ties in with the warranty period as well for these large batteries. So when a system is being designed, the load profile on the operating profile of how that battery is going to be utilized will be given to the battery manufacturer, which is typically Samsung or LG, and they will then warranty that battery depending on what your load profile is. Okay, and that will typically be for a 15-year period. If your operating profile changes and you don't tell the manufacturer, then the warranty becomes invalid. If you do, then the warranty period will change. So what I'm trying to say in a roundabout sort of way is the lifetime of the battery is, I think, a lot longer than what we're expecting. In terms of disposal of the batteries, I don't really know the answer to that. I don't know if anyone in the audience has any experience of where we're going to go to with lithium-ion batteries. I know there are companies around, and I can't remember the name of them, who are utilizing electric vehicle batteries for energy storage systems.
Eaton are doing that with Nissan batteries,
yeah.
Nissan Leaf batteries, and
yeah.
there are others as well.
Yeah, so there is a recycling market there in place already from the automotive sector into batteries. So that's a start, but how that will impact in terms of large scale, megawatt size scale of batteries at the end of their life, I'm assuming there'll be some sort of recycling, reuse type of system. I don't know. Rupert, have you had?
As far as I know, reusing the lithium, recovering the chemicals, and making it possible to completely recycle it properly, that is not really happening yet, but it is generally assumed that at some point someone's going to take that seriously, but no one's really doing it yet. Maybe there's just not considered to be enough critical mass in the market yet to do that.
I mean, managed batteries last an awful lot longer than the laptop battery.
Yes.
I mean, this idea of recycling automotive batteries into grid storage batteries is actually a shortage of automotive second-hand batteries because they're lasting a lot longer than they're connected. Yeah. So yes, at the moment we haven't even got to that. Actually,
yeah,
we can recycle them.
To make an observation,
yeah, sure.
What will actually drive the recycling of lithium-ion batteries will be the automotive industry. Once you start getting a couple of million cars on the roads with lithium batteries, that's going to drive the whole life cycle.
Yeah, I think my concern on that is, from what I understand, is that when these batteries are from the automotive sector being taken into the energy sector, they will have I think you have to have a minimum charge level, 80–90%, which is fine. But you don't know how it's got from the 100% to the 80%. If it's been, if the car's been driven nice and smooth, so the battery's had a gradual decline, or it's been a rapid decline, which I think will then degrade the battery even faster. That's my only concern. But
I was just talking about volume. If you've got a very high volume of, people having containers for electricity storage is not high volume. 1 million cars on the road with electric batteries, that's an awful lot of batteries. Yeah.
Yeah. I have heard designs, instead of having I can describe it, instead of having a battery in your car which you charge every day and every night, it's a bit like an Uber. So you will So say I go down to Weymouth, which I do quite a bit. So I'll say I'm going to go in my electric car. I'm going to go from here down to Gloucester services. I'm going to arrive at 10 o'clock, change my battery. Yeah. So a lot of the charging mechanisms will could be different, a different business model. Okay, that de-risks the charging at home, but I don't know. I'm sure there's other business models as well. But yeah, I think what we're saying is correct, that the automotive sector is going to drive the market. There'll be two, the automotive sector and the energy market. How they will, I can see there are opportunities, but I'm not totally convinced around utilisation of automotive batteries for energy generation. But I'll probably be proved wrong. Yes.
My question, because batteries are so expensive, is where are the batteries? So in terms of megawatts for the UK, my guess is that most of the megawatt hours of battery storage are in cars at present.
Yes.
Would you agree?
As a
Because you've got to follow you've got to follow where it is and then think, let's use it.
Yes, that sort of ties in the previous comment, wasn't it? There is a market there, and there are businesses set up to do that. Where I'm sort of focused on is on the larger scale, the megawatt scale of batteries.
Right, but you only need 40 cars with 40 kilowatt hour batteries, and you've got a megawatt.
You have, and there are opportunities around vehicle to grid mechanisms.
Well, not at present.
But there are systems coming in now that you can utilise vehicle to grid. But
so who do them? Were any of them at Boston, for instance?
I can't come. I don't know.
Okay. So, but for me, I don't know of any that I could lay my hands on.
What you mean, vehicle to grid systems?
Yeah.
There are. I mean, I know we provide electric charging vehicle systems as other companies do, and there are. I think the issue is more around the contractual arrangements of a vehicle to grid opportunity of how where do you get the energy from and who you're selling it to. I mean, another thing on that, which is probably worth mentioning, is one of the issues around there was a misconception is if we all in this room, there's 20 of us, 20 of us, we all got electric vehicle, we all go to High Cross on a Saturday morning and we all need to charge our car up. So there's always a concern there's going to be a rapid rise of demand on the grid which can't be supplied because we're intermittent and all that sort of stuff. What will actually happen with smart charging systems coming in is that they will monitor the state of charging your car, and when you arrive you'll put into the machine how long you're going to be there for, and it will work out when it's best to charge your car. Maybe the first hour, maybe the last hour. Yeah. So the rapid increase on the demand on the grid will not be there. It'll be more of a leveling. Yeah. Rupert.
Yes. So on that point, what's important, particularly at the moment, and I suspect for quite a long time yet, is not for putting the electricity back into the grid from the vehicle, but what you're alluding to, which is the smart charging, which when you've got thousands, millions of vehicles plugged in around the country, is the ability to put energy into that huge aggregated storage pool.
Yeah.
In ways that can manage, which essentially is just controllable demand.
Yeah.
That is incredibly important and removes much of the need for battery, for stationary battery capacity. And once that energy is taken out of the power sector and put into the transport sector, it will be consumed for transport purposes, and it's unnecessary to put it back into the grid. I think, although vehicle-to-grid systems are just beginning to come online, and not really in a particularly commercial way yet, the actual need for putting that electricity back into the grid is still really pretty rare at this stage. Much of the time it's just about, so if you look at the difference between how stochastic supply like wind arrives, it comes in huge, spikes because there's an energy there's a weather system passing across the British Isles, for example, you will get 2 or 3 days of an enormous input coming from from offshore wind. You've got to get that into something quickly. And if you've got millions of vehicles out there that will take all that, that's fine. As that weather front passes and that wind input sort of cools off a bit, actually just the system as it normally is will take care of the more steady demand, and there's not really going to be a great deal of need to start pulling that stuff back out from those cars. So it's because the input comes in spikes, but the demand is relatively steady.
Can I chip in with a question?
Yeah, sure.
Before we finish up, I'll bring together 2 questions. One, this is representing Dennis in Africa, and we got Wahid in Dubai. So the question really is one of supply of lithium-ion batteries. Are they sensitive to the actual climate? Because both Boston and the UK are fairly temperate. Is there any more challenges when they're running a warmer climate? And the other query, probably not so much for a problem in Dubai, but certainly in Africa, is the cost of lithium ion, and whether in the Western economies we're rather better off in terms of being able to procure lithium ion than some other areas in the world, and whether that's going to be a challenge.
Yeah. Okay. So 2 questions there. I mean, the first one really is just a environmental climate control system really within your containers to maintain your batteries at reasonable temperatures. So wherever you are in the world, it shouldn't make any difference. The other question is actually quite interesting, because up to the end of this year, there's been a shortage of lithium-ion batteries from respected manufacturers, because the South Korean government passed some sort of grant mechanism on companies to install batteries. So 75% of the world's supply of lithium batteries has been sucked into South Korea, which provides a little bit of a shortage. However, having said all of that, that is coming to an end. So as we move into the next year, then that will start to open the market back up again. Obviously, Samsung, LG are the main suppliers, certainly in the UK. I'm not quite sure across other parts of the globe. Does that help to answer the question, Tim?
Yeah, well, it gives some context anyway. Whether that means it may be more available, whether it's actually accessibly financially accessible in markets such as Africa.
Yeah, sorry, that was sorry. So in terms of commercial viability, that's a difficult one to say without looking at each individual project and what you're actually trying to achieve, and different incentives from each country. What we have in the UK is different to what it will be in other parts of the globe. So difficult one to comment, but I think Rupert might have a comment on that.
We've just introduced Africa's first solar-powered taxi service into the Gambia, where we're looking at exactly these sorts of issues. And the key thing in Africa to bring down costs is to amortize them across the lifetime of all the equipment. And because the total cost of ownership can be cheaper than running an internal combustion engine vehicle, for example, and if you have a way of amortizing that cost across the lifetime, actually it does win out. So the key is all in the business model.
Yeah.
One of the ways in which our system works better than an internal combustion engine is because we don't pay for any fuel. Yeah. We simply recharge from a solar-powered mini-grid anyway. Yeah. So that has a big effect on the lifetime of on the whole life cost of the vehicle.
Yeah.
So I don't know the answers to it precisely, but I'll get, if you get back to me in a couple of years' time when we run the field trial, I can tell you how that all works out.
Yeah, I mean, if you take to raw economics on a life cycle basis, roughly 80% of your life cycle costs are operating costs. So if you can drive that operating cost down, like Rupert has just said, because you've got no fuel because it's free, and you've got less maintenance because you haven't got a internal combustion engine and all the issues around all that, breaking down spare parts, fuel supplies, then the economics should start to be much more attractive.
Thank you very much.
Okay. Make it last question.
Yeah, and a positive one. I've looked at, I know we've spoken a lot about batteries tonight. I've looked at batteries, and with all the market incentives, I can only get it down to 4.5-year payback. But I'm going to be going back to my office and adding my load shaving, because I've got standard distribution curve, and it's just those few small periods which cause my maximum demand. So thank you. I'm going to go back. I'm going to rework those figures. And hope that the income increases at the same rate that the price of batteries is coming down.
It's certainly, I don't know what it's like elsewhere in other parts of the globe, but certainly in the UK, it's the non-commodity costs that we're trying to control here. So it's the transmission. What we have to pay is for the cost of electricity being transmitted down the main HV grid and then down the main LV grid into the mainly on campus types of sites, and it's these non-commodity costs which is what we can affect. The actual tariff itself, the price of electricity, we can't really affect. So as Scott was saying there, by utilisation of batteries, we can minimise those or reduce down those non-commodity costs, which makes the business model more attractive. On that happy note.
Well, thank you very much, Duncan, for a fascinating talk.